Lesson 7D, Glomerular Filtration. You'll recall that the paired kidneys filter blood of toxic waste of metabolism. Each kidney contains roughly 1 million nephrons, which are the functional units of the kidneys. Each nephron begins with the Bowman's capsule, which envelops a bundle of blood capillaries called the glomerulus. The blood arrives to the glomerulus via the renal artery, which subdivides into blood vessels called the afferent arterioles. At the narrow part of the glomerulus is a structure called the juxtaglomerulus apparatus, which is a ring sphincter that can squeeze, creating an increase in pressure. This is similar to putting your thumb over the opening of a hose, which creates a higher pressure stream of water. As a result of the increased blood pressure, blood will travel at high speeds through the glomerulus. This forces the small components of blood, such as water, salts, urea, and whatever else is small enough to fit through the wall of the capillary bed, into the opening of the Bowman's capsule. This process is called glomerular filtration, where the capillary wall effectively acts as a filter. This is similar to pouring water through a coffee filter. The water will dissolve small bits that are small enough to fit through the paper to make coffee. Because the blood is under pressure due to the juxtaglomerular apparatus, and the walls of the glomerulus acts as a filter, we can also call this pressure filtration. The material that makes it into the Bowman's capsule of the nephron is called the filtrate, and will include small, dissolved components of plasma, such as water, nitrogenous waste like urea, and ions like sodium and potassium. Large components of blood, such as red blood cells, white blood cells, proteins, and sugar, will not fit and will remain in the blood. Blood from the glomerulus loops back and exits via the efferent arteriole, which branches to create the capillary bed that wraps around the entirety of the nephrons. We call these the Peritubular Capillaries. These are used to reabsorb the important components of the filtrate back into the blood, such as water and salts.